Hello once again, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek into my personal experiences. This is a channel designed with you in mind. Let us dive into today's lesson. In this continuation of the lesson on IUPAC naming, where we said the IUPAC stands for the International Union of Pure and Applied Chemistry, we came out in the previous lesson with the rules of naming this of alkanes. By the way, guys, this is currently limited to alkanes, which are number 1, hydrocarbons, number 2, saturated. Don't forget that alkanes are hydrocarbons which are what? Which are saturated. So we kind of looked at this part and we went on to kind of introduce the lesson further when we looked at the branches, where we introduced how do you go about naming of branches. Now it won't be easier for you to understand the lesson if you are still you did not get hold of the previous part of this lesson. So we also looked at this one. This was one of the first good examples that you can find in an exam, where we named this molecule with a branch, and I explained to that, and then we ended up on this one, which kind of had quite 2 branches. It was interesting, and then we had ended up settling to say the actual name was 4-ethyl 5-methyl-octane, not 5-ethyl 4-methyl-octane. Why? Because we always look at the list numbering. So if you haven't gotten hold of the previous lesson, it means you won't be able to cope or fully understand this coming lesson. That is, if you are an underdog. If you think that you can cope, let's go on. But guys, subscribing is very important. You need to subscribe so that you don't miss out on such. Let's look at the next one. We are looking at IUPAC naming. We are continuing. Let me make this one a little bit smaller for the sake of fitting in the picture here. Look at this. We need to keep the name to the structure. Now, the aim of this is always to identify the longest chain. Remember, you can read it from left to right, or you can read it from right to left. What is important is the numbering. You always have to settle for the numbering, whether it's the most numbering or the least numbering, but I'll show you as we get more practice. First of all, let's look at the parent chain. Parent means the longest chain, or the root. Some books, they use the root, the parent. How many carbons are we having, or the line that we can draw without breaking the chain? I can move from here. This is always the common one, but it's not every time that the straight line is the longest chain. Let's look at the number of carbons. It's 1, 2, 3, 4, 5, 6. So 6 carbons. Now what if I go up? Still the same look. Make it a bit thick. This is still the chain. I didn't break. You see, it's a straight chain because I didn't break my line here. So this will be carbon 1 here. So I've got carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Well, that is it's not the most. The parent chain must have the highest number of carbons. So that's not the one. I can't go up. What about if I want to move in this direction but go down? So I've already 4. This will be 5. Again, no. You see? So the first one is giving me 6 carbons. The second one is giving me 5. The third one is giving me 5. So it means these are not the ones and these are not the one. The one that is correct is the straight one, which is the longest carbon. When the straight one is the one that I want, which is this one, it means this is a branch, and it means this is a branch. Now, for me to be able to have a better structure or better view of this molecule is to make it into a condensed structure. And then how does it look like? This is carbon 1, carbon 2. So carbon 1, carbon 2, 3, 4, 5, 6. So let's draw it. I've got CH3, CH2, and then CH. Now let me pause there. It's CH, so let me leave it like that. Then there is a branch here. Look at the branch. It's how many carbons? 1, 2. It's a branch with 2 carbons. Remember, it's ethyl, which is what? CH2 CH3. This is a CH2 CH3 branch. So you circle it to say that is a branch. You continue with the chain. That was in carbon 3. Then you have got again CH. But look at down there. There is another branch which is simple 1 carbon. So it is a CH3. So we circle this one also. Then we continue. That is 1, 2, 3, 4. Carbon number 5, it's CH2. In carbon number 6, it's CH3. I think that. So this is the chain. You can just verify the numbering. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. Now when you have done that, remember this is from left to right. What about if I want to read it this direction? Let me use yellow in this case, not red. If I want to read it this direction, what I have: carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. Always read it in both directions. I will encourage you. Now let's come with the naming bearing those two conditions, to say from left to right and right to left. So let me try to divide here. Let's start with the one from left to right. What name are we coming up with? So we can say that in carbon number 4, remember we said this is the branches. We call this the ethyl, and we call this the methyl. So let's come to say in carbon number 4, look at this. In carbon number 4, we start with E. Remember, E before M. In carbon number 4, then hyphen, we've got ethyl, right? And then in carbon, then you put a hyphen. In carbon number 5, this is 1, 2. Okay, I'm not doing it right. I'm looking from, remember, left to right. So in carbon number 3, this is the one from left to right. In carbon number 3, I've got ethyl, and in carbon number hyphen, in carbon number 4 hyphen, I've got methyl. Are you getting that? So in carbon number 3, I've got ethyl. In carbon number 4, I've got methyl. I'm looking from left to right, remember. So it's 3 and 4. And then the parent chain has got 6 carbons. And 6 carbons is what? No space. It's hexane. So it's 3 ethyl, 4 methyl hexane. Now what about from right to left? Meaning this direction. Look at this. In carbon number 4, I've got ethyl, and in carbon number 3, then hyphen, I've got methyl, and then it's hexane. And then I say to you, which one takes priority? It's ethyl. Why? Because E starts before M. So this then becomes the wrong one. Why? Because look at it. It's carbon number 4, and then it's carbon number 3. You take the smallest numbering. So the right name is that one. This one is wrong. That's how you do this. Alright. So this is the naming, and you need to get used to it. It will, the more you get used to it, it ends up getting comfortable. Look at this one. Another IUPAC naming. Always identify the longest structure, and so on and so on. Always that, I mean, not really always, but it's always good to just take the basic one that they give you. This is the basic one they give us. Then let's count how many carbons. It's 1, 2, 3, 4, 5, 6, 7. Then let's check the one that is going up, because it's another one with the longest. Is a chain here going up. How many carbons? 1, 2, 3, 4 5, so it's not gonna do. If I can take this one, look at this, I can start this from right going up, it's also allowed. So it will be 1 2 3 4 5 6 7. It's also giving me 7, maintaining with the other one. So it means it doesn't matter whether I chose the horizontal or the going up one, it will still give me then the same. But if I try to take this one here like this, you can see it's simple 1 2 3 4 5. Even the other one like this, it's 1 2 3 4 5. So it's not gonna do. So I know that my longest chain is what? My longest chain is 7. Either I take it like this, see, I didn't break line, or I take it like this, I still didn't break line. So let me use the standard one, which is the straight one. So let's use the straight one to say it's the one that we're going to choose. Since I'm using the straight one, the next thing I need to do is to say this is 1 2 3 4 5 6 7. Now look at the branches. You've got 2 branches now, actually 3 branches. You've got that as a branch, you have got that as a branch, and you have got this as a branch. Do you see these branches? Now what branch is this one? It's in couple number what? In couple number 3. So in couple number 3 you have got an ethyl branch. Why? You'll see why I'm calling it. In couple number 2 it's a methyl branch. Why? You'll see that. In couple number 4, so this is couple number 2, and then in couple number 4 you have got an ethyl branch. Now if I were to do a condensed structure of this is what it looks like. It is going to be CH3, and then in couple number 2 it's CH3. I always prefer doing a condensed structure like that. Then it's CH there, and then you've got CH again, and then I've got CH2 and CH3. See that? And then I've got CH going down, it's CH3, and then I've got CH2, CH2, CH3. If I look at the number of carbons just to maintain here, it's carbon number 1, carbon number 2, 3, carbon number 4, 5, 6, 7. So far so good. And then this is my branch. As we said, it's ethyl. Then this is a branch, it's methyl, but it's in carbon number 2 hyphen. This is in carbon number 3 hyphen, and then this is a branch for methyl. Now how do you name this? As we said, always look at E. Since there are 2 branches, methyl and ethyl, E starts first. So what you have in carbon number, we are looking at the naming that gives ethyl the smallest numbering. So if I move from this direction, it will be 1 2 3 4 5 6 7. Look at now our ethyl. Ethyl becomes carbon number 4. No, carbon number 5. So you see that 5 is already out. So if I move in this direction, ethyl is in carbon number 1 2 3. It's in carbon number 3. But if I move this direction, it's in carbon number 5. So we are moving from left to right. Gives us the simple numbering there. I think that. So it will be what? 3 ethyl. Don't forget the hyphen between the number and the letter. 3 ethyl. Now look at the most important thing now. You have got 2 methyl and 4 methyl. So this is not this is how you write it. You say hyphen 2 : comma 4. You don't say 2-methyl and then say hyphen 4-methyl and then you continue. No, you don't do that. You don't write it like this. What you do, since they are all coming from methyl, so how many methyls do we have? We have 2 methyls. We have got in couple number 2. Now a number and another number, you separate it with a comma, so it's 2, 4, and then because there are 2 methyls, you say hyphen di. Di means there are 2. If there were 3, you're gonna say tri. So there is dimethyl, there is trimethyl. If there are 3, so there is, which means one is mono, but you don't say mono. So it's 3-ethyl 2,4 dimethyl, and then the longest chain is heptane. Don't space. Are you with me? So that's how you come with the numbering on this. So let's go to move to the next one without spending much time here. Let's look at this one. Now, are you able to write the name without because of my time here? Let's try to write the name from here. The longest chain here, it most looks like this is the longest chain. Okay, let me do this. Just pause this. Tell me the name of this. Just pause. Come up with the IUPAC name of this one and then compare your answer with that of mine. Can you do that for me? Please do that for me. Now, this is how you would have done it. You do that. As I said, it's always good to come with the condensed structure. But if you are getting used, after some time, you'll see that this was a branch. And this was the branch. So there are 2 branches. Now, the naming, the guy that we have, this is ethyl. And this is methyl. Now let's start numbering from left to right. It's 1, 2, 3, 4, 5, 6, 7, 8. This is the direction. Now let's number this direction. It's 1, 2, 3, 4, 5, 6, 7, 8. See, now they tricked you here. Look at this. Since we have to start with ethyl, you see that going from left to right, it's the number 5, but going from right to left is the number 4. So you take the smaller one. So it will become 4, that is from right to left. I'm saying that now. So it becomes what? If you're moving from right to left, it is 4 hyphen ethyl hyphen 5 hyphen methyl, and the longest chain we say it is what? It's 8, and then it's octane. Alright, that's the name. Now let me look at this one. Not complicated, also not complicated. It wants the longest chain, and let me just see the longest chain here. I think it was still the same. This is the longest chain, and this becomes a branch, which is an ethyl branch, and this also becomes a branch, a methyl branch. This becomes a branch, a methyl branch. So this is couple number 1, 2, 3, 4, and 5. Even if I go from this direction, look at it, nothing changes. It's in couple number 1, 2, 3, 4, 5. Am I right? Now, which one is the longest? The one with methyl. Remember, this is methyl. Both of them, they are in couple number 3. See that? So simply it's 3 methyl. Are you getting that? 3 methyl. Doesn't matter whether it's from left to right in this case. 3 methyl, and then hyphen, you have got 2, 4. Both of them, you see here, even 2, 4, nothing changes. Then since there are 2 methyls, because this was methyl and this is another methyl, what do? If there are 2 of them, you don't say 2 methyl, 4 methyl. You say 2, 4, 2 numbers, and then you say dimethyl. because there are 2 of them. And then longest chain is 5, then it's pentane. Don't space between methyl and pentane. Are you with me? That's how you name this. Now let's come to this one. Just moving a little bit faster now so that I can just do this in under 24 minutes. Look at compound E. Say, draw the structural formula from the given compounds E and F and write the IUPAC names of E and F. Now, you need to be able to draw a structure from what is given. Look at this one. How do I draw a structure from here? I'm given CH3 and then CH bracket CH2, 3, and then that and that. Start from the condensed form. You have got CH3, and then do that. They are saying there are 3 CH2, so it's CH2, 1, CH2, 2, CH2, 3. That's what they're saying. Then after that, you have got CH, CH, and then there are 2 CH3. So the first one is CH3 here. Now you can put the other one up there and say CH3. Always maintain the carbon with 4. So this is what is having. There are 2 of them. Now look at now the structure. You see, from the condensed form, you can come up with what? With the structure. So the structure becomes C, H, 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 C, H, H, C, H, H, C, H, H, and that is done. And then C, C, H, H, and H, and then you've got H and C, H, H, and H. There is the structure. That's why they say come up with a structure. And then what is the name? This will give us the name here. What is the name here? The name of this, if you look at the lowest numbering, look, when I'm numbering this one, it's carbon 1, 2, 3, 4, 5, 6. So you see, this is a branch, it's in carbon number 5. But if I number in the lowest direction, which is this one, it's carbon number 1, carbon number 2, carbon number 3, carbon number 4, 5, 6. So the methyl is the one that determines the numbering, this branch. So is it 2 or 5? Smaller numbering, it's 2. So it's 2 methyl, and the longest chain is 6, which is hexane. The other one was supposed to be 5 methyl hexane, but 5 is a bigger number. We don't take that. The correct answer becomes that one. Alright, now look at the other one. Look at the other one. My time is already up after 24 minutes, but let me try to push this so that I finish this. Look at this one, F. If you had to draw compound F, look at this. It says there are 3 CH3 groups, CH. So how is it like? It's like you've got CH3, and then here I've got another CH3, and then, because there are 3 of them, and then I've got CH3, and then it says I've got CH. See, that now starts confusing. So what you do, you remove this one, and then you say here CH, and then here you've got CH3. Look, we have got 3 of them. This is CH3 1, CH3 2, and actually this is not allowed, 3. Let me just do this properly again. Let's do this properly. That was wrong. Remember, when you draw, it must have maintained 4 carbons. Let's do it again. There are 3 CH3, so CH3, and then you've got C. This is now much better. CH3, and then CH3, there it is, and then you've got H. That's CH. Look at this. 1, 2, and 3. It maintained that. Do you see that? So the structure of this compound becomes like this. So there it is CH3, there are 3 of them in CH. So when you do that, the structure becomes, if you take it from already from here, what will be the structure? You've got C, C, H, 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 and then C, H, H, and H, C, H, H, and H, and you've got H. There is the structure. What is the name? This is the structure, but the name you are going to get it from here. The name is always better from the condensed structure. Look at this. What is the longest chain? Very important there. The longest chain is more like this. Look at this. I can draw the structure like this. CH3, CH, straight CH3. Then in here I've got a chain CH3. Do you see how it's like? So the branch becomes what? This one. Longest chain, 3 carbons, and in carbon number 2 I have a branch, so it's 2-methyl what? 3 carbons is what? Propane. I'm getting what I'm getting. You need to be able to pick up such things. Alright, then let's look at the last part, because I wanted to come here to isomers. I gave this intentionally. It says a compound X is tested and found to be hexane. Hexane. Give the structural formula of compound X. In other words, they're saying, give us the structural formula of hexane. Now, hexane, hex means 6. Start with the condensed structure. Hexane is CH3, CH2, that's 2 carbons, CH2, that's 3 carbons, CH2, that's 4, CH2, 5, and CH3. So this is carbon 1, 2, 3, 4, 5, 6. Hexane looks like this. Then the structural formula, remember, they need to show every bond that is possible. So you have got 1, 2, 3, 4, 5, and 6. And then you come up with the actual structure where each bond is shown in each atom. Remember, the definition of a structural formula is very important for you to know that one. So there is hexane. Number 2, give the structural formula. This is the most important question now. Give the structural formula and IUPAC names for all the possible isomers of compound X. Possible isomers. That's where now I wanted to come in here. So we come up with the isomers, but after that we need to name them. Let me show you how you come about this. When you're dealing with isomers, let's start with A, first compound. First compound, try to cut it there so that it can have 5. So when you're cutting it, it will be 1, 2. Okay, let me do this. When you cut it, condensed structure first. CH3, 1, CH2, 2. The longest chain must be 5 now. CH2, 3, CH2, 4, and then CH3. Cut it there. Then after that, put a branch like this. Whatever you cut, it will be this one. It becomes a CH3 branch. Do you see that? It's now there. So if you still count molecular formula, structural formula, the molecular formula will still be the same. So that is the first one. So how do you name this? This is in carbon, because the smaller naming is from here. So it's carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So in carbon 2 we have got 2-methyl. So instead of hexane, now it's 1, 2, 3, 4, 5 pentane. That's the first one. Remember, we are moving from hexane. The first isomer. Remember what is an isomer? Same molecular formula. Now hexane, it's C6H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What about 2-methyl pentane? C6, because it's 5 carbon plus 1. This is carbon number 6. How many hydrogen? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me do it again. 3, 4, 5, 6, 7. There is a problem there. You see, that helps. Now, this was a problem. I cannot have 2 here. I can only have 1. It's CH. You see on the structure. So it's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. H. 14. Same molecular formula, but different structure. So if I'm to draw the structure of this guy, it'll be here, C, C, C. So I've got here this, and then I've got that in carbon there, and then how many CH2, CH2, I've got that. Now look at this, that's why I said I've got H here, then I've got C. See, when I was saying I cannot have CH2 there, and then I've got C, H here, H and H. So it's 1, 2, 3, 4, 5. That was the one. That's the first one. What's the second one? Where can I cut now? Okay, I don't need to they said as many isomers as possible. I can now move this guy from here in carbon 2 and place him in carbon number 3. If you place him in carbon number 3, so this was the chain isomer that I'm having here. It's a chain isomer. The chain has changed. Chain. Now the other one, it becomes now a positional isomer where the same chain is there but the position is changed. So if I change that, what will I have? This is what I'm going to have. Look at this. I'll have CH3, CH2, CH, then I have it there. CH3, see? I just moved it to the next. And then after that, I've got CH2 and CH3. It must be 5. 1, 2, 3, 4, 5. Still maintained, but now in number 3, whether you are moving from left to right, I've got now 3 hyphen methyl pentane. Again, it will still be C6H14. Are you with me? What is the next isomer possible? I said here you're cutting there. I can actually now, I've done with this one, I can cut it here now so that I can make this a branch. I see that. So if I can do it this side, where can I do this? Now the longest chain is 1, 2, 3, 4. Let's make the longest chain 4, which is CH3, CH2. I'll remove that CH2. I said the longest chain is 4, CH3. So this is my longest chain. I cut there. Where can I put it? I can remove one of these here and put a branch which is like that, which is CH2, CH3. Now unfortunately that is not, but I'll show you why this is not right. Because if you look at the longest chain, my longest chain will be like this. 1, 2, 3. You see? So if I'm to look at the longest chain, this is 1, 2, 3, 4, 5. It will still maintain the previous one that we did here. Look at this. This is the okay. Let me do it slowly. This is the longest chain. If I look at this, I've got C. There is the hydrogens. I've got C. There is the hydrogens. I've got C. There is the hydrogen there. Then after that, I've got C. There is the hydrogen. I've got C. There is the hydrogen. I've got C with this hydrogen. So if I look at the longest chain, it will be this one, and in carbon number 1, 2, 3, there is a branch. So it will be 3-methyl pentane that we tested. So this one is the same. So let me come back and look at it again. A structural formula that I can come up with. Alright, let's come up with this one. Let's erase this because we saw that it's not. Let me come up with 2 methyl branches. Look at this. Remember it was hexane. So I come up with 4. I cut it to 4. 1, 2, 3, 4. Then here I've got C. So let me do it like this. It's CH3, CH, CH, CH3. I come here, I've got a CH3 branch. I come here, I've got a CH3 branch. Do you see what I'm doing then? Then, see, I'm doing it long this lesson because I wanted you to master this. So look at this, in couple number 1, couple number 2, couple number 3, and couple number 4. It doesn't matter whether you name it from the top. Couple number 1, 2, 3, 4. You can see that in 2 and 3 you have got branches here. So these are called what? Methyl. So now if I draw the structure here, I will have it like this: H, 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 then C, H, and then I've got C, H, H, that's a branch, and then C. Let me put it on top, this one, so that they don't crowd at the bottom. Doesn't matter, guys, where you put it. And then C, H, whether you put it on top or at the bottom. So this is the one. So what do you call this? This name of this compound, in couple number 2 we've got a methyl, comma, in couple number 3 we've got another methyl, then you put a hyphen because there are 2, we call them dimethyl. What? The longest chain is 4, then it becomes butane. Alright, so then this becomes more of the 3 isomers, and then you can see now what is this? These are chain. This is another example of a chain isomer. It's chain. Why is it chain? You moved from what? You moved from 6, you went to 5, from 5 you went to 4. So these are chain isomers of this structure and the names involved. So guys, this is the end of the naming or the IUPAC naming of alkanes. I'm yet to look at the IUPAC naming of alkenes and also of alkynes, but now it will be much quicker because usually they maintain is just the functional groups and all the other possible functional groups that we can now find from the previous ones, be it haloalkanes, be it alcohols, be it ketones, be it aldehydes, be it carboxylic acids, as well as esters. Now we have to come up with the simple IUPAC naming of these. So that next lesson is going to be kind of mixed up with many of these, and then I will also focus later on alcohols in particular because they've got different namings, as well as focus on esters because they're a bit different. But with esters, it comes when you look at the reactions. We have come to the end of our lesson. Remember to subscribe and ensure that your notification bell is turned on to be notified every time I do a new video. We've come to the end of our session. Thank you.